I'm going to take you through 4 U-substitution examples, starting with the integral of 2x e to the x squared. With U-substitution, our goal is to rewrite this integral as some function in terms of u, and then identify its derivative, du. I'm really undoing the chain rule, so I'm looking for layers of functions. When I'm looking for layers of functions, this e to the x squared stands out. So I'm going to go ahead and let u be x squared. So look for those inner layers. That's a great way to start your u substitution. So I'm going to let u equal x squared. I need to replace everything in terms of x in my integral to be instead in terms of u. That means I also need to replace this x, and I need to replace the dx. I've got the x squared covered. If I take the derivative of u, I end up with 2x. Now technically this is du dx with respect to x. You can also think of this as implicit differentiation, but however you get there, when you take the derivative, you want to hang on to the dx as well. So now I've got my 2 pieces for substitution. I'm going to replace x squared with u, and I'm going to replace 2x dx with du. Let me rewrite this integral so you can see exactly how I'm replacing these. So 2x dx is going to get replaced with du. I'm going to leave that e there, and then I've got u here, which is my x squared. I'll put a green box there around my x squared. Okay, let's do the substitution. So this is equal to, in terms of u, let me go ahead and do the function first. This is going to be e to the x squared. X squared is u. Everything that I've got left, the 2x and the dx, the 2x and the dx are du. So I'm going to write that as du. So I end up with a really nice integral. I've got now, in terms of u, the integral of e to the u du. Well, the integral of e to the u is just itself e to the u. So I end up with e to the u. This is an indefinite integral, no limits of integration. So I want to put that plus c on the end, and that leaves me with my very last step, and that's to put everything back in terms of x. I've got e to the u, but u is equal to x squared. So this becomes e to the u, e to the x squared plus c, and that's our answer. Here comes the next one. For this next one, I again want to replace everything that I've got here in terms of x to be in terms of u instead. And I look for that innermost function. It's a really great place to start as you are working towards the integral in this form. I want some function in terms of u and du. Let's go ahead and start with that inner function 3x plus 1. I'm going to start that for my u substitution. So u is equal to the innermost function 3x plus 1. I also need to replace the dx. To replace the dx, I'm going to take du. As I take the derivative of 3x plus 1, I end up with 3. The derivative of x, I'm going to record that as dx. Now I don't have a 3 in my expression here. I'm just replacing a dx. So I'm going to go ahead and isolate my dx by dividing both sides by 3. So du divided by 3 is equal to dx. These are my 2 substitutions. So I'm going to replace 3x plus 1 with u, and I'm going to replace dx with du divided by 3. I'm going to rewrite my integral really quickly so you can see exactly where those substitutions are going to take place. So I'm going to leave my cosine, but inside the cosine, I've got 3x plus 1. That's going to become my u, 3x plus 1, again, that innermost function. And on the outside, I've got my dx, and that's going to become my du divided by 3. Let's do the u substitution. So replacing my variables, I end up with still the cosine. 3x plus 1 is u. And I can replace dx with du divided by 3. du divided by 3. I can pull that divided by 3 outside of my integral as a 1/3. So I'm going to write this as 1/3 integral of cosine u du. What a nice integral, right? I know that the integral of cosine is sine, so I can go ahead and take the integral. So this is 1/3 sine of u. Again, this is an indefinite integral, so I want to remember to add that plus c. My last step is to replace everything back in terms of x. So specifically, I need to replace this u with 3x plus 1. So as I go back in terms of x, I get my 1/3, I have the sine, and I'm going to replace u with 3x plus 1, and then I remember to put the plus c on the end. As we're working with this one, we again notice that layering of functions, the composition of functions in our numerator, ln x all to the third, but I also recognize that I've got the natural log and its derivative, which is 1 over x. So I'm going to let u equal the natural log of x, and du, taking that derivative, gives me 1 over x, and then I'm going to record the dx. I'm going to rewrite this so you can recognize where everything is going to get changed. So this is my du. Okay, so in my original integral, I've got the integral of, I'm going to write this as the natural log cubed. The natural log is going to be my u, and then I'm going to pull out that 1 over x, and I'm going to rewrite that one in green. So that 1 over x dx is going to get replaced with my du. Here comes the substitution step. So changing my variable into u, I have u cubed. So there's my u cubed. And then everything on the outside there, 1 over x dx, is exactly du. So I can go ahead and put du here on the end. I just need a really nice power rule on this one, a nice integral to work through. So I'm going to increase that power by 1. I get u to the 4th, and I divide by my new power 4. Again, this is indefinite. In my next video, you'll see some with limits of integration, some definite integrals, but this one's u to the 4th over 4 plus c. I've got that one last step, and that's to replace u. So I've got something to the 4th here. U is, in terms of x, the natural log of x divided by 4, and then plus c. In this last example, the u substitution is going to work just a little bit differently for us. I want to make sure I cover all the different types that you might see. So in this last one, I do have that innermost function, a really great place to start with your u substitution. So u is going to equal x plus 1, but I don't have du. I have part of it. The derivative of x plus 1 is just dx. That takes care of the dx here on the end, but it does not take care of the x out here in front. I'm going to do one more thing with that u substitution, and that's to solve this one for x. I also need to replace the x. So you can think of this as having 1, 2, 3 expressions in x that need to be replaced in terms of u. If I solve this, I get u, if I subtract a 1 from both sides, I get u minus 1 is equal to x. Let's record all of our substitutions. So I have u minus 1 is equal to x. U is what we started out with. U was x plus 1. And du, we took the derivative, and du is dx. I'm going to rewrite that integral so you can see where everything goes. So x is going to get replaced with a u minus 1, so that's one of the things I've got to replace. In my parentheses to the 9th is my original u substitution, so this is going to be x plus 1 here. And then finally on the end, I've got my dx. So in this case, I'm using my u substitutions in 3 distinct ways as opposed to 2 distinct ways. I'm ready though for my u sub. Okay, so here it comes. Let me see if I can keep track of all of these colors. So in terms of u, x is equal to u minus 1, in parentheses, u minus 1. And then I've got my value to the 9th power, that's x plus 1, my original u. And then on the end, I've got dx, and dx is now du. Let's write this so that it looks a little bit cleaner. U minus 1, u to the 9th du. I just need to distribute that u to the 9th so I can use a power rule term by term. So the next step, u times u to the 9th is u to the 10th. Negative 1 times u to the 9th is negative u to the 9th du. Now I can go ahead and integrate term by term here, and I end up with u to the 10th. I'm going to increase that power by 1. I get u to the 11th divided by my new power, minus the integral of u to the 9th. The power goes up and I get u to the 10th divided by my new power, which is 10 plus c. To finish this off, I just need to go back in terms of x. So I need to replace this u and this u with my original definition for u. Doing that here in my last step, I'm going to end up with u to the 11th, but in terms of x, u is there in orange, x plus 1. This is divided by 11 minus u to the 10th divided by 10, but u is x plus 1, and then I've got my plus c there on the outside. Take a look at this next video. It covers definite integrals, integrals with limits of integration, and u substitution. Thanks so much for watching.